All right, we're back. A little bit of a venue change as the computer was dying, so I had to move to where the charger is. So, example 2, this is algebra 7-7, interpreting exponential models. A car's value, v of t, so that tells us that that's what v of t is. V of t is the car's value, can be modeled by the function blah, where t is the number of years after purchase. So explain what the 22,000 and the 0.805 represent or mean in the context of the problem. So context of the problem, always key to be writing a sentence about what the problem's talking about or what's going on there. So just per usual, that 22,000 is in the spot of that initial value, that first piece, that starting value. So I'm going to start off the 22,000 represents the initial value of the car before it's purchased. That's starting value. Okay, so now the percentage piece, a little bit tricky this time because you can see that we have a percentage or a decimal that is less than 1, which tells us that this is going to be decreasing, that we have a decay situation or a percent decrease going on. Excuse me. Okay, so just like we started off with the one above, that was a increase, we had to first start by taking that decimal and converting it into a percentage by multiplying it by 100. So if I take this decimal and multiply it by 100 times 100, that gives me 80.5%. Now, you might be thinking that 80.5% is the percent that it's decreasing by, and that would be nice. It would be nice if it was that simple, but it's not that simple. And I'm going to hold you off for a second. I'm going to bring you back to our example from previous lesson. When we looked at that community college having its population decreasing by 5% each year, the number that we used in that formula wasn't the 5%. It was the percent that was left over, that 95% of the population that was left. So that's exactly what's going on right here. That 80.5% represents the percent left over after it's decreasing. This desk is a mess. So the 0.805 represents the 80.5% of the car's value that is left. That's a terrible looking left. That is left after decreasing by blank. We're going to fill that in. What percent each fill in time is year. Okay, so just a quick little bit of math here. If we have 80.5% that's left over, what percent's being taken away from that? We would just real quickly do that 100 minus the 80.5% to get 19.5%. Just gonna double check my math real quick. 100 minus 80.5. Good job. I preach what I tell you guys. I tell you guys to double check. I mean it. So that decrease is the 19.5% each year. Really, really important that you're taking the time to do that so you can get full credit on this problem. Otherwise, you're not going to get full credit. All right, and part B, it might seem very similar to the part B in the other one, but it's not. So how much will the car's value change from year 3 to year 4? Change, remember when they ask you to find the change in something, change just means subtraction. It's not asking for change in Y over change in X because it didn't ask for average rate of change. It just wants to know how will the value change from year 3 to year 4. So first we need to find out how much it is on year 3. And then we can find out year 4. So V of 3, replacing the 3, or the T with 3 because that's the year. 0.8 sketch 0.5 raised to the 3. 22,000 parentheses 0.805 caret raised to the 3. Boom, saucity sauce. We're talking about money. So all money gets rounded to the nearest hundredths. So 11,476. 11,476 and 52 cents. Remember, in a situation on a test, you want to be showing me the decimal first and then rounding afterwards to get some partial credit. If, God forbid, you make a rounding mistake, because, hey, you're a human being. Funny the way that works. Isn't it, though? Oops. Okay, so 9238. 9238.60. Okay, so how much did it change? We're just going to subtract those two. 11,476.52 minus the 9238.60. 11,476.52, and that gives us 2,237.92 is how much it changed from year 3 to year 4. Boom! There you go.